Good afternoon, everyone. Welcome to Lecture 7 for Packaging 450, Automotive and Industrial Packaging. Today, we are going to start on Chapter 3, which is testing. I'm going to share my screen. Okay, can you see that, Brandon?
Yep.
Okay, great. So again, Chapter 3 is testing. Okay, before I go any further, I just want to say a couple things. So first, I think pretty much everyone has turned in assignment 2, which is great. I have not finished grading Chapter 2, but I did notice on Chapter 1 that there seem to be couple of papers, couple of returned in assignments that almost had the exact same answer. So I understand if you're copying and pasting from the chapter reading, but it's important that you use your own words and describe things in your own terms, using the terminology, of course, but you just want to make sure that, you're doing your own work. And, it's important because once you start working, you want to make sure you have a good understanding of what's going on, because usually what's happening is pretty fast paced. If you decide to go into really any job, but specifically automotive, one of the keys is don't ever stop the line. So if you're going to work in automotive and you start work, you don't want to go in and try to relearn something that was covered in the class because, you maybe had previous information, and then the line stops because you're going through a learning curve. So I just want to reiterate that. And again, Michigan State does have a strict policy on cheating, so just want to make sure that you are doing your own work and it's not something that can be plagiarized. So just wanted to bring that up. I will be, again, planning on finishing the assignment 2 checking and giving feedback on that by the end of this week. Again, if you have any questions about any of the homework for Chapter 3, I'm going to make sure that that is set up in the system and you can see it starting this afternoon. And if you have any questions on it, anything, you can email me, you can send me a note on D2L, you can come to office hours on Friday, or you can set up office hours at another time if necessary, if none of those things work for you. But I'm always here to help you with the homework and answer your questions. I'm going to have a couple pieces of supplemental information today that you can have just as an FYI as we talk about test methodology. And again, the supplementary information does not tie in with the homework assignment, but it's something that it's good to keep handy as you go through your job. So specifically with the test information that we're going through, will be something that you either want to hang on to or know where to reference it and find it. So I think those are my comments for today. All right, so Chapter 3, testing. So some of this stuff, this is going to be some review for any of you that anybody that has taken the transportation packaging or any transit packaging or anything like that, any of those courses, or if you're interning at a test lab, a lot of these things are going to be review for you. Brandon, since you're on again today, if you have any questions, feel free to jump in. And if anyone else has questions or comments as we go through this, as you watch this, feel free to, send me an email and I'll bring it up during the next lecture from when I receive that. I also, as I go through, check these assignments for Chapter 2. So last thing for Chapter 2, I will review the Chapter 2 homework after everything has been checked. So just want you to know that. All right, so back to transportation. So as you know, trucks specifically are moving in six different ways. You're going to see roll, heave, sway, and surge are basically, if you were to plot this on a graph, you basically have X, Y, and Z directions. A roll is a combination of heave, which is going up, Roll is the other direction is going to be sway. So you can see as the truck, you don't ever want the truck to roll over, but in case it ever does, that's called sway. Surge is, again, going forward, you're going to catch surge when you have yaw, which is going to be surging forward, as well as the sway, which is the side to side. And then pitch is going to be the other one. So pitch is going to be your heave, which is up and down. And then it will also be the surge, which is front to back. So that just gives you an idea of what the truck will do. And of course, this doesn't just apply to trucks, it applies to rail cars and sea containers as well. So, anytime you're moving a package, you're going to be looking at movement in these directions. And, that's really what you start looking at when you start encountering things like damage. So as you can see here, when the truck moves, when it's on the road, you're going to see, things like potholes. You think about potholes, or you think about big bumps in the road. But I will tell you, years ago, I worked for UPS, and one of the things that they would tell people when you're shipping a product and you're trying to package for it, when I would go out to customers, they would say, one of the events that you're going to see happens many times at the beginning of the trip or the end of the trip. It's when the truck pulls into or out of the parking lot, and if it runs over the curb. So if you've ever seen a truck run over a curb, that could be considered an event. That could be an event that causes a shock. So, you're looking at things like braking and accelerating, besides, the road condition. But the other one is vibration. And that is where we talk about the main hazard, because if you are hitting the resonance frequency, that can cause considerably more damage, because it amplifies the vibration when the truck is moving at a resonance frequency of a particular product, and that amplifies the force and the damage that you see. And this is what it talks about the resonance. So, when you're looking at things like electronic components, which we see a lot more in automotive packaging, things like the resonance frequency, as well as shocks, but the resonance frequency is one of the things that is key. So when you start running packaging testing, that's one of the things that they check for, is what is the resonance frequency of the product, so that that if the resonance frequency of the product that amplifies that vibration and causes a lot of damage, falls within the frequencies of the test shipment that's similar to a truck vibration, or sea container or rail car vibration, that's pretty much going to give you an indication that you're pretty certain to have some sort of damage to your parts. So some of the things that you are looking for, again, with automotive packaging, as far as damage, you're looking at things like damage to the board, solders or welds on the board for electronic components. But then when you have things like Class A surfaces that are painted or visible to the consumer, those may be prone to scratches or dents. And those are things that, you want to make sure you're protecting against as well. Okay, so this talks about one thing that's important, leaving a 2-inch gap between the stack of what's on the pallet and the walls of the trailer will help reduce the amount of damage that you get when you're shipping. I'm gonna pull this over. Okay, I don't know if you can, did I share my screen? So Brandon, can you see this, or do I need to share the whole screen, or am I just sharing the document? Can you see this FedEx?
Yep.
Okay, so I pulled this up because This is pretty common in small parcels. So you see this with UPS or FedEx or anybody that's shipping express shipments. But you will see here, they have a box here. So what they're saying is this is specifically for if you're shipping a product to be tested. But I wanted to show this because it kind of illustrates that 2-inch rule. So this is what they really want to test, but they're putting it inside of an outer box, and then they're making sure that they have some sort of protection between the test product and the outer box that is shipping. And they're doing that for that particular reason. So, you know, in the small parcel environment, you're not going to see things like fork truck damage because everything is going to be going on conveyors or handled by hand, but you will have that vibration on a truck the same way you would with a full truckload of the same parts going for automotive. But I just wanted to show that very quickly because it does really give you an idea of, you know, why that 2-inch gap is important. Sorry about that. Okay, let me get this off my screen. Okay, so so that's when that's the main hazard when you're transporting product. Like I said, this is talking about trucks, but you'll see vibration on trains, you'll see vibrations on sea containers, you'll see vibration as you're shipping, you know, on conveyors. But the next main hazard is when you're unloading and loading trailers. So in automotive, you're looking at pallet loads in general. You very rarely are shipping individual parts. So, you know, you may have a company that's shipping small volumes for certain things, but even if they're shipping LTL or less than truckload, they're still going to be using pallets. And that was where I talked about the AIAG standard 48 by 45-inch pallet. So again, that is one of the standards because the assumption is most things are shipping on pallets. So when they're unloading the truck, many times you're going to see it's really based on the experience of the truck driver. So you can have an inexperienced truck driver who is unsteady and they may be, you know, dropping loads a little bit harder than they were meant to be dropped. Or you can have an operator that's really experienced and they're so experienced that they're very quick. But in order to be very quick, they might pick up 2 pallets at a time. So let's say this is being loaded into the truck. They have these 2 pallets and they're so quick, they're able to pick up 2 at a time versus an inexperienced driver may pick up 1. Pick up those 2 and they're moving pretty fast. I've worked somewhere where they put governors, I think I mentioned they put governors on the forks so that they wouldn't drive too fast, so they wouldn't cause these impacts. But the fork drivers figured out how to bypass the governor so they could still go like 15 miles per hour or something that was really fast. And then for that environment, and then they pick these 2 up and they load it on the truck. And because they're experienced, they can move pretty fast, but they may not be able to gauge moving at a faster speed where this ends. So they'll just run the pallets into this one. So now you've caused some sort of event with these 2, but then you also cause an event with this one hitting these 2 pallets, the impact of these 2 pallets, but then that impact is also going to push this pallet up against the trailer wall. So that's where that 2 inches comes in handy. So, you know, those are just examples of some of the events and hazards that you see. Okay, so another one, I guess, would be, you know, going up and down hills, stopping suddenly, braking, going downhill. This is rare, but this is something you want to be aware of. Every once in a while, I would hear about, especially a truck full of racks. The racks are very heavy. The racks are heavy. The trailer may be going uphill and the racks are heavy and they push out the back of the trailer. So that's something else that you want to keep in mind. let's see, what else can I tell you about this? Let's see. Okay, so now we'll talk about rail cars. For rail cars, they, like I said, they are very similar to trucks, but you don't have the potholes or bumps. So you don't necessarily see the pitching and heaving like you would, but you can see that they have in the couplers, or this is where the rail cars are connected, they have basically shock absorber, and the body is connected, by a spring. So that's kind of how it works. Also, you have a suspension here at the bottom, so that on the rail, as it's going along the rail, you can see this is not exactly even. So they have ways to accommodate that. Hold on for 1 second. I'm so sorry. I have a little interruption here. Unexpected. Okay, can April let him in? Okay, hit the number and then the lock. You have the code? Yeah, so just start over. I'm so sorry. Sorry about that. The hazards of having a home studio. Okay, I'm back. So this tells you about how the rail cars are designed, and how the design is made to stop the rail cars from, front to back shock events, because they have shock absorbers in the couplers, and then the up and down with the suspension, but then also, you do get some side to side as they go down the track. So you've got a couple of ways that, you're dealing with up and down here, front to back, and then they also deal with the side by side. Now, there are a couple of different terms. So you've got the rail cars, they call it hunting, when the rail cars move from side to side. And so the cars are trying to follow that uneven track. But you also have when the rail cars are moving, from front to back as they stop. So you have things like switching or transferring, those sorts of things. It's referred to as coupling, but what you'll probably hear, the term you'll probably hear in the automotive world is shunting. So if you're running testing on, say, racks or some packaging for a rail car run, your product's going to run on the rail, they may refer to this as shunting. And a lot of this is, when the cars are stopping and they lurch forward, when the rail cars, when they stop at their final destination, sometimes if the rail cars go into the building, they will have a large bumper at the end of the track. So it will stop the rail car from pushing through the building and going past the track, but it is a shock event for whatever is on the rail car. So you have a couple different types of suspension. So, I mentioned before that you can have racks that can be heavy. The racks tend to carry the heavier products. They're bigger and they carry more, more products, but they also are made to carry heavier products. So you get things like engines, and this is going to really refer to larger engines. So I worked in an engine plant that made the 4-cylinder engine. So those were for the really small cars. But when you start looking at diesel engines or, V8 engines or V12 engines or anything like that, those can be much heavier. So while the smaller, like the 4-cylinder engines aren't going to necessarily weigh out a truck, for example. The other ones, the larger ones will, so you're not going to be able to get as many on a truck. And when they ship by rail car, you're going to see more issues with the suspension. So you want to make sure you have heavy duty suspension and stiffer suspension for those types of products. Any questions so far, Brandon? You know, you're acting as our student questioning person.
Yep, no questions right now.
Okay, great. So, you know, one of the reasons why when you look at the suspension on rail cars, what's important is to really limit the amount of movement. So even though they're moving on uneven rails, they're moving up and down, they're stopping and starting, they have shunts, they're transferring from one rail to the other, you know, anything short of derailment, you're going to see a lot of events for the rail car itself. But the rail cars are designed with shock absorbers and couplers so that you minimize those events. Let's see, what else do I want to mention? So, you know, you want to make sure you're still going to see things like where they can rub up against each other. So you have something that has a surface that you don't want to get scratched or could damage it. You still need to protect against that. But as you can see, this example of these parts, they are more anchored down so that they don't move. And, you know, that's really what they're protecting against. You can see this is an open bed rail car. So obviously this is something that you don't need to protect from moisture like you would on a thing, you know, something on a sea container is going to get, if it gets wet, obviously this doesn't matter. The big thing is that you don't want them to move. You don't want them to hit each other so that they don't get deformed or, you know, broken from deformation, basically. Okay, so anytime you have a new automotive product or new packaging, you want to make sure that you test your packaging with the parts in it. So you want to get parts that are as close to production as possible. So you will hear a term called production intent. You want to get a part and packaging that is as close to what you would get in production as possible, because you want to simulate not only the environment that is shipping in, whether it's a truck or a sea container or a rail car, you want to simulate that, but you also want to use the parts of the packaging that they will be shipped in. So you just want to make sure that you have that. Again, I mentioned this before. You'll notice I keep saying this. So here it says the biggest problem with damaged parts is not necessarily the damage itself. It's can stop the assembly line. You don't want the line to shut down. So if you're making a product, okay, I'll give you an example. I have a client right now that they are shipping parts that are they have a lot of electronic components. So they're very delicate. They're, you know, sensitive to everything an electronic part would be sensitive to. They're shipping small volumes right now. They have a pack that they're shipping UPS or FedEx or, you know, small parcel. They're shipping it like next day air, but the volumes are really small. At some point when the volumes go up, they won't be able to ship. They're not going to be shipping. It won't make sense for them to ship it next day air. So they're going to have to start shipping it. Some of these are coming from overseas. Some of the parts are coming from, you know, within North America, but they made a pack that passed testing for small parcel, which means you're looking at going on a plane or going on a truck for a short distance on, you know, paved roads, and also handling, you know, by hand. These parts might go on a conveyor or they might get picked up and carried by hand. So the test sequence for that is based on what that supply chain looks like. Versus, you know, with larger volumes shipping overseas, So, okay, I'll give you the example again. They're shipping right now, FedEx or UPS, they can ship it on a plane halfway across the world and bring it into their dock. Long term, though, the supply chain could be they put it on a truck, they're shipping it within a country that may or may not have paved roads. In some countries, they have bridges that they do maintenance on a regular basis. When those bridges are out for their regular PM, then they're required to put anything that would have crossed that bridge has to be put on a barge and shipped across the river. So now you've got a truck on unpaved roads, then the parts get taken out of that truck and put on a barge, and then they get taken off the barge and put back on a truck, going through may or may not have paved roads again. Then it goes to port and gets put on a boat, and then on that boat it gets boated over, over 4 to 6 weeks across the ocean on a sea container. Then it lands at the port, gets opened, checked at the port and the border for customs, unloaded, maybe warehoused, put on a truck or train. And let's say train, that's the worst case scenario as far as hitting every mode. It gets put on a rail car, and then it gets trucked after, gets to the rail car, and it gets trucked to the final destination. So, you have literally, 2 modes of transit where you have it put on a small truck loaded by hand on the conveyor. Then the second one would be it's on a plane. And then you go back to that first mode of transit, which would be a small truck, and it gets unloaded by hand and moved into the dock for whoever. So you go from that to all those different scenarios where I talked about boats and barges and trucks and rail cars. So you have to understand, it's really important to understand that supply chain, because if you do, so going back to that customer I mentioned, they've tested everything to ship small parcel, but once their volume picks up, that test sequence doesn't mean anything. So they could have damaged parts because they haven't tested the packaging through that environment. So the last thing they want to do is stop the line with these parts. So they, made some changes to the packaging based on what they think the new environment will be. And then they will have a transit test to validate that. Okay, so again, that's why I say, the issue is, you never want to damage parts, of course, but the issue is making sure you don't disrupt the line by running out of parts. By the parts show up, and let's say the first box has damage. Now, how do you determine was that the only box that's damaged? Did something special happen to it? Did it get dropped at some point and we didn't know? Or is this typical of the rest of the shipment because the testing maybe didn't capture all of the modes of transport? So this mentions here, the best way to test these parts is to load them and then, watch them as you ship them. So what I found is, you really want to run a lab test when you can, because what the lab test will do, you want to do this as early as you can during your development process. So basically, when I say as early as you can, I'm saying as early as you can get production intent parts, and as early as you can get packaging that's going to reflect as close as possible to manufacturing. So the sooner you can get those 2 items and run it through a test lab, the better, because what that does is it's going to show you if your packaging is going to protect your product, is it going to be reasonably protective, or you're going to have a catastrophic failure. So you're looking for that. And then once you get that data, then you can tweak your product and your packaging and make sure that, anything that popped up that could be an issue, you've accounted for that and made those revisions in your packaging. And sometimes you end up, it has to be a revision to the part. I have one customer where I'm looking at the part, and they showed me, they said, we shipped this and all the parts were damaged. And I looked at this entire box of damage. And, I said, well, were they in the same spot in the box? What was going on? And they showed me the parts, and the parts were all damaged in the exact same spot. So it didn't really matter what part of the box they were in. The exact same spot on every single part broke. That told me, yes, the packaging wasn't protective enough, but it also told me that this was clearly a vulnerable part of, and vulnerable spot on that part. So, sometimes you take that information and, let the engineer that's designing the part know that, and then they might come to the conclusion that we might need to make this part a little bit more robust, because if it didn't go through and it came damaged and it was tested, transit tested, and it went through the same way that it shipped the same way we tested for transit, which in this case was next day air, then we can reasonably think that this has more to do with the part than the package. But once you rule that out and you know that your package needs to be, tweaked or changed, and you make those changes, then you want to do a confirmation test by shipping it on, actually sending a real shipment of it out to look at it. And I think this is something that is true regardless of what you're doing. I can give you examples of, when, things went through and they did all the calculations and the lab testing, but then when production really hit and you go to ship it, you start seeing damage, because nothing simulates a packaging shipment like a real packaging shipment. So you want to, again, make sure here you want to do it well ahead of production. So I talked about doing lab testing to validate and qualify. You want to do that well ahead of time, but as soon as you get those lab results in, then it passes the lab test, you want to ship it and test it. And a couple of things that are important when you test that I found. So right now, this is just my own knowledge I'm telling you, not necessarily something that's on a test, but when you ship something to do a confirmation transit test, you want to make sure that you want to take pictures, you want to really capture the product, what condition the product was in, what condition the packaging was in. You want to log all that. And then secondly, and most importantly, on the other end, the receiving end of that transit test, you need to make sure you have someone that is ready to receive the parts, ready to receive the packaging. They understand what you're doing as far as that this is a test. You want to mark the box really well. You want to, if you can have some sort of tracking number, or have someone in receiving following the shipment, when it's coming in, so that whoever is on the other side that's going to analyze it, they know when it's coming and they can go intercept it. Because many times something that's not going to production, people don't know what to do with it and they sit it on a shelf, and then you spend more time looking for that than actually running the test. So with that being said, you want to make sure that you have someone that's on the receiving end that is ready and willing to do an analysis of the product and the packaging when it gets to its destination, when you do this transit test with the actual shipments. And you want them to understand what the criteria would be for a pass or fail. So if, let's say this is a part that is going to a dealership, right? It's not consumer driven, or it's going, let's say it's going to the line, and maybe the box is really dirty. the criteria going into a production plant, if it's a plant, if there's sensitivity to the plant, to the part getting dirty, that could play into whether or not it passes or not, your test. But if it doesn't really matter, you want to make sure that that's clear. So if the box is dirty, is it important? If the box has a hole in it, is it important? I think in general, you probably don't want a hole in the box, but there may be some, there may be some exceptions to that. Next, you want to make sure that besides having the criteria of, what's pass or fail, you just want to be clear. You want to have a way for them to score it. So when I say score, you want to make sure that they rate what this means. Is it dirty? Is it pass or fail? If you have whatever your point system is, you want them to use the same system that you would use. Because as you start doing these validation tests for products throughout your process, you want to have the same system that you're ranking them for. So you just want to make sure that that's spelled out and is understood by whoever is on the receiving end of this testing. And then the other thing is they need to take pictures. So you want to make sure that when they receive it, they take a picture of that box when it first comes in. What does it look like? Does it look damaged? Is it crushed? Is it open? Is it wet? Whatever, you want to make sure, does it look perfect? And then you want them to open the box, take pictures of what it looks like before they take anything out, whether it's a dunnage or part, whatever's in that box or tote or bin or rack, you want to take a picture of it, the interior before you take the parts out. And then you want to take the parts out and you want to examine the parts. Are they, if it's a Class A surface, are the parts damaged? Are they scratched or cracked or anything like that? Is there anything that's dented? Is there anything cosmetic? If it's something that's, say, prone to water damage, is it rusted? So, just that's where, you really need to understand what the criteria is for your part. Next, the other thing that you want to do is during this whole inspection is the part functional? So you have a part that's functional, that could be, does it fit? So if you have a car door handle, keep referring to that one, did the brackets bend during shipment? Can it be installed on the vehicle? Or let's say you have a DVD player that goes into the back of the headrest on a vehicle or the back of the seat. Does it turn on? Does the part, you have a headlight, does the headlight turn on? So does the part function as intended? Those are things that you need to do. So besides that visual test, that visual check of the outer pack, the interior and the part itself, you also want to make sure that it's functional. So, and again, you want to do this before production starts, because this is probably going to be your last chance to make revisions before you kick off purchasing large volumes of this packaging. So it mentions here, the preferred test method is to simulate your handling and transportation in a lab, because that gives you the first chance to see, are there going to be any problems, what you can anticipate. And the tests are pretty good at reproducing, because the truck sequence for vibration, for example, over time they can simulate what it looks like. And I've even seen in some cases where, you have certain routes and they put accelerometers on and they're able to read the accelerometers and they have a really good idea of what's on the route. Maybe it's a really bumpy route, maybe it has a lot of hills, whatever. And I've seen it where if a company is if they know what their routes are and that well, they could actually take the accelerometer data, put it into the vibration table and run that as their sequence. So, it can get as detailed as that. But in general, you want to try to simulate what is going to happen in your shipment. So it's really important to understand everything that's happening, anything that could cause damage, anything that could make your part vulnerable. And you want to really confirm that your packaging is protecting against this. And, it's depending on what your part is, depending on what your pack is, depending on your ship mode, it can, there's so many different variations of what could happen. Brandon, I'm gonna ask you if you have any questions right now.
Yep. So I was actually wondering, because you just mentioned the vibration table, but which one do you think gives more accurate results? Just going through an actual transit with the products, or simulating it using like the vibe table? Since I know the vibration table uses random vibration testing, but you can also, like you said, program.
I am a believer that the real transit test, actually running it through the system, is your final confirmation. That's going to tell you what you need to know. For me, what I found, this is my personal preference. For me, the lab is a guide. You can program, you can, have the information, and it can help you with your design process, and it can help you know what the hazards are. So if you're not sure, okay, so for example, some of the electronic parts, sometimes companies or engineers, they may not know what the fragility of their part is. And that means they don't know what the resonance frequency is either of that part. So the lab testing is really important to understand that. And then once you understand that, you can, work on designing a protective pack for it. But either way, in the end, you still need to, I believe, in my experience, it showed me that you still need to run it through a transit test on an actual truck or train or however it's shipping, because you just don't know. When I worked in, I think I mentioned before, when I worked in an engine plant, we had racks that were going to Mexico. They were going by truck and they switched it to rail. We ran some testing in the lab and everything looked fine for rail, on a vibration profile for rail. When I ran the final test going on a rail car with actual racks and engines, we were planning to use them if everything went fine. They actually had a mudslide. They were going to Mexico. They had a mudslide. They had a heavy rain, a mudslide, and the train derailed. And most of the racks were fine. So that was good news, that most of the racks were fine. This was probably the most catastrophic event you could have on a rail car, would be a derailment. And they did really well. So, we were certain that the lab testing reflected what happened in real life.
Gotcha.
Yeah, so we didn't have any issues, and we actually were able to use quite a few of those. I think we used all but maybe a dozen of those engines that were on the racks from that derailment. So I hope that answers your question.
Yep. And then another thing that I remember in an interview before, they had mentioned, I guess the transit aspect would also help when it comes to the atmospheric conditions, because a vibration table can't necessarily simulate what's going on with, I know they mentioned like you're traveling, it's an international company, so it starts off, like you said, traveling by road, then starts traveling by air. So I guess putting it through the actual transit would help with that as well.
Yes, because you can put something in a humidity chamber and see how it responds, but that's not going to be the same as putting it on a sea container, which we know that they're not airtight or watertight. So you're going to get water in the sea container no matter what you do. It's a very humid environment. And then I got to remember which one it is. So if you're on, well, really, you're going to have the roll, the heave, the sway, the surge, the yaw, the pitch. You're going to get all of that on a on a sea container, you're going to get all of that. And it's pretty significant because if you see how big those boats are, and they're on the ocean, the movement of those it's really, really, really extreme. So yeah, especially when you're shipping. I think when you're shipping by sea or by ocean, you want to, the first load you get in, you want to make sure they're okay. So you don't, I would say if you can push to not assume that this first shipment overseas is going to be fine, that you want to get those and say, provisionally, we want to make sure that these are fine. They pass testing, but provisionally we want to inspect these. So you might get pushback because everyone's like, oh, we just need to go and get it done now. But if you can get that first load overseas and back first, early, you want to do that. I also understand things have changed in the last 2 years with the pandemic and supply chains and things being backed up. It may not be the desired way to ship something, but if you know something's coming by boat, you want to get that testing done as early as possible. You want to get the first shipment in early and double check it, because that gives you time to fix things. Because I don't know what it is now, but pre-pandemic, you assumed it was minimum 6 to 8 weeks if you're shipping something by boat. For it to get across the ocean, for it to get through customs and make it through, you're assuming that from the time that it ships out, from the time that you receive, is going to be 6 to 8 weeks. And I know that that's changed a lot during the pandemic with all the supply chain issues, and they are not back to normal. And I don't know if they will ever be back to normal, to be honest with you. So you want to make sure that whatever that cycle time is for shipment, that you get that first shipment checked out first. Because if there are any issues, let's say that you ship that first shipment out and you find out you have issues and they send another shipment 4 weeks later, you're basically going to end up with 2 loads of product. Because if it takes, we'll just say you're good and everything comes in six weeks, and they ship the next shipment 4 weeks afterwards, and it's a catastrophe, or you have some issues with moisture or damage or whatever you might have, that second shipment's probably going to be the exact same way, and you can't stop it because it's already out on the ocean before you've gotten your test results back, or I won't say your test results, but your review of that first shipment back. Does that make sense? Is that clear?
Yeah, it makes sense. Makes sense.
Okay, I know it's a lot, but just kind of thinking out loud here. So, okay, so we talked about that. We talked about the hazards. We talked about accelerometers. Okay, so the accelerometers are good because it gives you a lot of data. I'm going to bring this up. This is not in here, but this is a question I receive a lot from people. Can't we just put those readers that show the shock on them, right? Can we just use those? And they're just little, usually like almost labels that will go on to the product, and they put them on the side of the box, and it'll show whether the box has been tipped or whether it had a shock. But I found sometimes people would just actually go and just, hit them and set them off. And then they'll file a claim and say, these had some sort of shock event. So they'll file a claim to get paid for damages, and the parts are just fine. And I know that's not very often, it's not very ethical, but every once in a while it shows you that. So sometimes it's not even on purpose. Sometimes it just maybe someone just, sat the box down, not enough to damage the part, but just enough to set that sensor off. And or also tipping it, setting it down could cause it to tip, or being on a steep incline in a truck could cause that sensor to go off. And it doesn't correlate with whether or not there has been damage. So just because that indicator, that sensor goes off doesn't mean that there's damage. So I found that a lot of people want to use those, and I always discourage that because it's not the same as an accelerometer. Maybe the ones that show whether or not something's gotten wet might be good, but we see those in our phones, right? Where the I guess if you take your phone and get it worked on at, say, you go to the Genius Bar at Apple, and they open your phone and they tell you your phone has been wet. And you're like, I've never dropped this phone in moisture. I've never had it in anything, but it could have just soaked up. You could have been in a humid environment and it was just enough to soak up the moisture. So, you really want to take the sensors with a grain of salt. That's just my personal opinion. All right, so now we're going to get a little bit into testing. Okay, so you've got these are examples, accelerometers. What they can do is, they can show you anything from, any event, and some of them can even have GPSs in them so they can track where it happened. So this is where I mentioned that sometimes people take their accelerometer data on a truck route and they can run it through because maybe they're seeing damage on the same route. And they're like, why are we seeing damage on the same route? An accelerometer with the GPS, they can run it on that route and see, are they seeing a specific event at a certain time? And then they can actually see, where that's happening. And they go, oh, there is a big pothole, or, they did some road repair, but they didn't do it well. Or maybe the truck is turning into a parking lot, and when at that turn is causing the damage. It can get very detailed. And you can also see things like the temperature and the humidity too, which would be good on a sea container, but it can do it for several months. I don't see that very often, but it's possible. Okay, so this is a lot about what I already talked about, but this is on the technical side. So this shows you how they correlate the vibration test or any transportation testing that they do, how they can correlate that vibrational activity with what's happening on a truck. So, this is saying that, the auto industry hasn't had much success. So basically they put the recorder in the truck, they run it through the software, and then they put it onto the shaker, into the vibration table. I think that the reason why they don't necessarily see a lot of success with this is because the loads are not always uniform. So they don't always know what's coming. So you might see, and say like in food, for example, they might ship a whole truckload of the same thing. But if you are in automotive and you're a company that maybe supplies 10 different parts to a company, to one of the OEMs, you are going to be shipping mixed loads. And then if you're JIT to this supplier, so if you're a tier one that's JIT to the OEM, you're going to be shipping different things every day based on what the orders are. So I think that might be part of why it's hard to really capture some of this data and make it repeatable, because what you're shipping on the trailer isn't exactly what maybe was tested. So that's just something else to keep in mind. Okay, so they talk about the first thing is, recording vibration. Second step, you're taking in this information and you're looking at, power density. So, here's some examples. So at this point, you're taking the information, you're graphing, you're basically doing some math, and you're calculating based on the charts and graphs, what these waves look like, the frequencies of these events as the truck is moving. So here they're showing how, you have these would correlate to bigger events. So when you look at this, you start off, it's low, it gets high, it drops back low again. It goes back up again, not as high as the first event. And then these two they look equal, but remember, this is on a log scale. So it's not, this graph is not necessarily correlating with, it's not necessarily, say this to this is not necessarily that close. Keep those things in mind. I'm trying to think of what else would be interesting for you all. Again, you're taking this data from the truck, what's actually happening, converting it to the graphs and the frequencies, and then you should be able to, people that do this lab testing and they're very experienced with it, they can kind of see what some of these events look like, and they can tell, is this something like a pothole, or is this what happens when the floor is moving? Does this have to do with suspension in the truck or the train? So they can kind of tell. People that do this lab testing all the time, they can look at a chart like this and tell you what some of these events might actually be. So that's where they talk about, if you have a particular route where you're seeing a lot of damage and you run this sort of frequent test and look at their frequencies and, put it back and put it into the shaker, you should be able to simulate what's going on. So again, I mentioned here, that these are on a log scale. So here it says the two peaks that have power densities on an order of 0.001 and 0.0005 giga squared hertz. It's 10 to 20 times less. So even though they look like they're really close on the scale, they're really not. So as I mentioned before, people that run these lab tests, you have companies that's all they specialize in. They can tell that this is due really to the trailer moving up and down, and it's suspension related. So another thing I'll mention is a lot of companies like to use air ride trailers because they don't see as many vibration events when they ship, and shock events. So then the next step is to take that data that was plotted out from, again, real life. They look at it on this plot, and then they put that information into that vibration table, and they put it into the controller. And then when they run that test on the vibration table, it's basically simulating what happens here. So basically, you're taking that information, converting it, reviewing it, and then once it goes into the controller, then once you run that shaker, it should simulate the same thing. So if you see damage for a specific part here, it should simulate and be pretty close, theoretically. But this is where, they mention in the, where it's mentioned here earlier that automotive doesn't necessarily have success with that. And I think it has mostly to do with the variation of products that you can ship. You're not always shipping a whole truckload. If you're a large tier and you're shipping the same parts and they're large parts and you have many of them, you might be only shipping full truckloads, but many times the tiers are shipping to the OEMs mixed parts. So they'll have, you know, a mixture of totes, bins, racks, all, you know, custom bins that they're shipping. So in custom racks, you may not, you're not going to see the same thing every day. So that I really think that has a lot to do with it. Okay, so this table is showing you, this is what we most traditionally see, and it's only moving in one direction. It's up and down. But again, with the very beginning of this chapter, we talked about omnidirectional movement. So if you know that you are shipping, say, by boat, and you have a lot of, you know, movement, or shipping by truck and you have movement in, you know, all three axes, this may not really give you what you want. So now you're looking at, you know, 6-axis shakers, and you want to find a lab that can simulate that. Okay, the next one is the side impact, right? So this is where you're talking about like pallets marshaling or moving. When they move them on they could either slide on a truck on an incline, or when the fork truck driver is, you know, pushes them into each other. And I've actually seen fork truck drivers pushing pallets with pallets. So back to my trusty packaging again. So I've seen fork truck drivers take a pallet, push another pallet. Okay, so they're causing an event just by doing that. But that would be an example of marshaling. So when you start talking about side impacts, you know, you're looking at things like that that happen in the facility with fork truck drivers, but you're also looking at things like braking and turns, as I mentioned before, leaving a parking lot and hitting the curb. You know, those are some of the events that can really be can really be damaging to parts. Again, you've got, you know, the coupling. You know, this is when you're talking about rail cars. So, you know, you have where they actually connect the rail cars together. So one is sitting and the other one moves, and that's how they connect them together. Or when you get okay, so I'm going to show you. So this, in this picture, this reminds me of what you might see with a bumper stop at the end of a rail line. So a rail line is going into a building, they're going to have a large bumper that's about this size. And so that could also simulate that activity too, where the rail car is stopping. So, you know, these events are happening at, say, 10 miles per hour. It's really slow, but it's still, there's a huge amount of force that happens when this happens. Another one is when you see the train moving forward and it's yanking the cars behind it. Each car gets yanked. So that's another time when you have that type of event, and that's called take up. And then you have the horizontal impactor, which is going to simulate any impacts from the side that may happen. So there's that backstop that I mentioned. So that could simulate a rail car going to a building, hitting the bumper as a backstop, or could simulate one rail car hitting another rail car as a couple, or it could be, you know, when it gets yanked, or it could be a truck stopping, or it could even be a you know, fork truck driving into another pallet load. So there are a lot of reasons and events that you would use this to simulate. So this is probably what everyone's probably more familiar with, that you see in labs for consumer products, an incline impact tester. This is more traditional, but because the loads are larger in automotive and other industrial environments, you might see something more like this. Okay, now, this, I want to talk about some of the standards here. Okay, just checking the time here. Okay, so now we've got some guidelines. So the AIAG RC9, AIAG again is the Automotive Industry Action Group. They're based in Metro Detroit, and they basically get together. They have standards for across automotive, all different things. So they have a group that's involved with supply chain, and then under that, packaging and material handling activity falls under that. So they work on either creating new standards or updating standards that have been developed. And what that is for is so that you're basically, have expectations, you meet the requirements. So I mentioned before the palette standard. So part of the reason why you want a palette standard is, things, how many you can fit in a trailer, but also there are performance specs that are involved that are in that as well. So you have expectations on how the pallet will perform, what weight the pallet can withstand, what kind of force it can withstand, and so on. And same thing with bins. This talks about what tests are recommended, because the automotive industry has, as a collective, takes their experience and looks at, what are some of the best ways to test this packaging. So where it mentions here that the automotive industry hasn't necessarily had a lot of luck and success in taking a simulation from a reader and taking that information from by recording it and putting it onto a shaker. They have also because of that, come up with their own standards to say, these are the tests that we know simulate our environment and are repeatable and will help protect the parts using the returnable totes, unit loads of totes, any bulk bins, and then even the plastic pallets. So, there are actually tests with AIG for, something like this. Okay, so their guideline is called RC9, which RC stands for returnable container. And 9, they just have, multiple, I think RC12, I believe, is for the pallet. So it's just the number is just based on, what number, how many different guidelines they had at that time. So basically, the higher the number, probably the newer the guideline is. You won't see a lot of these guidelines that have lower numbers because they've been replaced by other guidelines. Okay, so enough of that. The tests that you see, so what they did was they took standard testing and they take for these bulk containers, you see an example of here. Here are some of the test standards that they use. Okay, so there's the ASTM D42. Okay. ASTM D 1083, 1185, 4003, the D4169, which is probably one of the most traditional testing. You'll probably, if you're working in any other industry for packaging, most likely they're using the ASTM D4169 in some shape, level, manner, or form. And then you've got the 4728, which is random vibration of shipping containers. Okay, so based on that standard, and one of the things I'm going to do, I'm going to pull those standards and see if there are any new standards and maybe talk about them tomorrow. But I think this is pretty exhaustive of what is being done now. I mean, I've seen some examples, and I was going to go over some of the things that I've seen where people are pulling out ISTA and those sorts of things with their testing. But I will tell you that I think a lot of that has more to do with the fact that, we're seeing more electronics in packaging for automotive products. And we're seeing, things like EV batteries, um, things that are more sensitive to either shock or even heat, like a lot of the EV batteries are sensitive to temperature. So they've had to add onto some of these tests because a lot of the parts in automotive are going to be either very heavy parts or maybe they're, smaller plastic parts like, doors or headrests that maybe have metal in them, or um, armrests, lights, the covers for lights, steering wheel covers, a lot of things that have, they're maybe plastic parts, but more than anything, they're more cosmetic. Or you may have machine parts that you don't want to, besides the cosmetic scratching, you have machine parts that don't want to scratch. So that's been traditional, but I think we're definitely seeing an increase in parts that are more sensitive to things like shock or ESD because of all the increase in electronics and componentry. So the first thing is that, you're conditioning and running the test in a specific environment. And you're going again with that 72 degrees and 50% relative humidity, which is pretty standard for a lot of the tests that you're doing, regardless of whether it's automotive or consumer, anything that you're going through a packaging test lab for. One of the things that this test does that you probably, I don't really see anywhere else, because with consumers, working with consumer products over the years, they generally had access to product. So they could, weigh the product down. But in automotive, there are going to be times when the parts aren't available until production time. So, and how do you test then? Because, you definitely want to test, but if you don't have a product, you've worked really hard to get it early on in, like I mentioned before last week in the previous chapter, you want to start requesting to have parts in phase 2. So when you start getting to phase 3 in development, you will have access to parts and you can start testing them, whether it's a lab test or whether you're doing, after you've done lab testing, whether you're shipping these parts. But sometimes, obviously, that doesn't happen, as you can tell, because they've AIAG in the standard, they accommodate by, putting in weights. And those weights would be reflective of the weight of the part or the weight of the load. Here is another test that is done. It's called stacked impact. And for that stacked impact, you can see you have containers that have the product on each, on top of each other. And there's a sled here. And once that sled goes into that backstop that we talked about before, so here's an example of the backstop here. Here's an example of the backstop here. So however that backstop is designed for that test, what you're trying to do is really figure out, what does that force look like on the bottom container? Because that's really where that's going to be where you're most likely going to see damage. If there's going to be any damage, the bottom container is going to be the most vulnerable. Okay. So EFW is the estimated failure weight. So again, that is based on what you're estimating because you may not have parts. Another thing that's important is that while the part engineers in automotive are making changes and running through approvals and doing all the paperwork to get the parts pushed through, they may not understand that packaging should be working concurrently with that. So this is where, as a packaging engineer in automotive, that it's really important to have a relationship with the program management team and the engineer who is designing the parts. Because sometimes if you go and look in the specification system for the part, normally what I would expect to find, and I would say with experience in other industries, the expectation is that there be a weight. That weight may change a little bit as you get close to production, but in automotive, I would say it's more prominent that you don't necessarily see a weight in the system. So you go in the spec system, you might have a list of parts, but they may not have a weight attached to them. So you don't know if this part weighs like an ounce or 10 pounds. So it's important to understand that, because that can make a huge difference in what the weight of the unit load is, what the weight is in the box. And you're, putting, if you have to put dummy weights in, you want to know if it's going to be a 1 pound bag, a 5 pound bag, 25 pound bag. That can make a huge difference between if you have a handheld tote and it's got 1 pound of product in it, maybe they're lightweight plastic parts, versus something that maybe is a 25 pound part in the same size handheld tote. Those are going to perform differently in testing. So you can, there's a way to calculate this. And the whole process is they'll run it so many times. But again, this is something that test labs do this, and they run this testing all the time. So for them, it's pretty standard, but it is important to understand how this works, so that you understand what they're doing. Because by understanding what they're doing, you can understand why they're doing it and what they're simulating. Because really, the lab test is supposed to simulate as closely as possible what is going on in the real world. So it's important to kind of understand, what these processes are, what the steps are, so that when you get out and start working and someone runs a test, you can tell whether or not this test is reflective. So giving the example of someone running very small volumes to start with, they're shipping at FedEx or UPS on an airplane, door to door, pretty much. But when they get into full scale production, it's going to be a totally different environment. So that's where it's really important to understand, if you have something that, if you test for a 1 pound product in a tote, and you say it's going to ship air express, that's totally different than if you have a tote of 25 pounds and it's shipping on a barge, on a boat, on a couple trucks, on a rail car. Totally different. So it's really important to understand like how these tests run, what the sequence of the testing is, what the purpose of it is, and does it meet what you need it for it to do. Brandon, any questions while I take a water break here?
Let's see. Yep. So I noticed that the bags were in the previous thing with the estimated weights of like what 5, 10, 5, 20, and 25. Okay, so are these bags also used for the top loading aspect? And like, where does top loading come into this play? Because that's what I'm seeing and noticing. It's like this reminds me a lot of the top loading process.
Yeah, so personally, I've not seen these used. Most of the time I push to get the product, so I've not seen those used. Let's see, we got sidewall impact, vibration, and we've got compression testing. So, I mean, that's what we have. Sidewall deflection, leg impact.
This is taking me back to the distribution center. All of these were in like the ISTA standards and whatnot.
Yes, yes. So I'm just gonna go through some more of these. I'm just looking at the time. I'm just gonna go through these in detail tomorrow, because there are a lot of tests here. But what I did want to kind of show you are some of the ISTA.
Ah, there we go.
Yeah, see. Okay, so okay, you all are probably gonna have flashbacks because I know that I do whenever I see this. But this is the STM D4169, right? And this is the table of, the cycles. So it mentioned in the AIAG testing that this is one of the sequences that they use, right? So out of 6, this is the number 5 out of the 6 that they use, number 5 on that list. So, this, you kind of actually have a menu that you can pull from, but you can see here, you've got like the general cycle. This is if you're not really sure what exactly you're looking for. You can specify for your user. This is if you have a pallet that's going LTL, there's no, sorry, there's a product with no pallet that you're shipping LTL. So this might be, you're having a truck, a 53-foot 18-wheeler pick it up, your product, and it's just getting loaded into a truck with pallet, fork truck, no pallet, I should say. So it's going to be picked up by a fork truck and just moved in. It might be something heavy and bulky that's going to go in there. This one is, you have a package. There's one package that's going to go on a pallet, right? And then you have something, this is motor freight truckload and non, or LTL. So you've got not unitized, which means that it could just be loaded onto a truck without a pallet. Unitized would be if it's on a pallet, but it's, pallet with, in this case, it's general. It could be boxes, could be totes, but, they are banded or stretch wrapped, or they have a cap and lid and seat belts in the case of automotive. This one's if it's only going rail and it's loaded by bulk. This one's if it's rail, but it's like palletized and, grouped units, unit loads. This one's if it's going rail and truck. Both of these, whether it's on a, a skid or not. Rail is going to be trailer on a freight car. I can't remember what that one is, but this would be if it's a rail and you've got like a flatbed, or you've got something that's covered, or regular container that we talked about. I think this was like a container over freight car. This one is if you're shipping, by air and motor freight, which would be like a typical FedEx or UPS overnight, where you've got like a small truck picking it up, putting it on an airplane and taking it back off of an airplane. Okay, this one is, and that's over 150 pounds. This one is basically the same thing, where if you're going, air from city to city, but you've got a small truck, that's a local truck that is a short trip, and this one would be up to 150 pounds. So this would be similar to like what you see with FedEx, UPS. There are also cycles for if you're warehousing materials. And one of the important things with warehousing is, when you get these containers and they're sitting, you're not going to see this much with plastic containers, but you might have some containers that when they're loaded on top of each other, they get fatigued. And then instead of them holding the weight of the product, now the weight is holding itself. So that would just be an example that you would see, probably more with something like custom containers in automotive, possibly. But more than often, when you see something like this, you're going to see it with corrugated boxes. I think probably the only time I've probably seen this is when you've had packs that have some kind of a sleeve around them. So instead of, you might have a pallet, but then there might be, it could be a corrugated, it could be a plastic corrugated, it could be, you know, different materials, but you have a sheet that wraps around and covers that pallet. Those depending on how they're designed, you know, might be something that when you're moving them, they have more of a tendency to shift, and they may not be necessarily holding all of the weight of the product. The product may be supporting its own weight. So those are some examples. So we got some other ones here. We got a couple more. These are going to be export import. These are pallet loads. The next one would be export import for what's called a break bulk cargo ship. So depending on the country, some countries are loading everything by hand. And I've seen things where they don't use pallets. They load it into the sea container, one container at a time, one pack at a time. And then when it gets to the port, when it lands at the port, they will have people that have to unload those containers by hand. So you might have, you know, hundreds of boxes, hundreds of bins that are on this truck or the sea container, it's now being put on a truck or rail car, but it has taken out by hand, and then it might get warehoused, put back on a pallet so that it can be moved to its final destination. I don't know anything about the non-commercial government shipments because that is all military. So I can't really answer that, but those are just some examples. I wanted to kind of go through what those look like so you kind of can see what they look like. Okay, here is the ISTA 3B, right? This one is when you're talking about packaged products that are for LTL or the less than truckload shipments. So I've seen this some in automotive because, you know, some of the parts, they may not have a full truckload, you know, especially if they're shipping JIT. For the OEM, they are shipping less than a full truckload to get what they need when they need it. Let's see. Okay, so 3B, this is going through everything. It talks about like the types of packaging that you have, gives you some definitions. And I think you can look this up and get this if you all just, you know, feel like looking it up. I'm going to post this as well, so you'll have it. It's supplemental, just so you can kind of get an idea. A lot of companies are adding what they feel like works for them. So we've got, you know, I think that's another reason why AIAG came up with this standard, because, you know, you can maybe get a company that they don't have a standard, so they can, you know, reference the AIAG standards and then pull, you know, what they need. But, you know, here we go. We talk about the conditioning at the beginning, and then they do shock. More shock. And you can see, you know, I mean, this one's all, you know, like shocks and drops. And then you got some more atmospheric preconditioning. So this one was for, you know, 200 pounds or less. This one is for over 200 pounds. Very similar, but you can see it spelled out literally step by step on what to do. But then you would go back in and see there are actually instructions specifically for these different tests. So if you want to see what the free fall drop looks like, you have those drops. It tells you like which corners and edges you're dropping it on. And then it even gives you a table of what those weights are. And based on that weight, it tells you what the height should be for that drop. And you can see here, you know, it tells you your vibration levels when you're doing your vibrations. Again, it shows you like what drop to use, the height for the drop. There's, you know, these are very detailed. I also had another ISTA so you could compare, you know, again, this one is the less than truckload. I also have one for the 3E. This one is for truckloads. Okay, so you can see here again, you know, this one is for unitized loads for a truckload shipment. And go here and you can see the sequence here. Why am I having trouble with this one? Okay, so you can see here that this one shows you, you know, the load spreader here. It shows by compression testing, but, you know, it shows you, you know, step by step, you know, which tests you need. And maybe one day I can scroll through here. This is very strange. Okay. Okay, so maybe they're only the first three, first 3 pages in here. But you can see the difference between the less than truckload shipment versus the unitized loads for a full truckload. When you just compare the two, you can see the difference in there. So it starts off with the atmospheric preconditioning, and then they've got the shocks and compressions, vibration and shock. And this tells you, you know, how you record for humidity and temperature. It refers to the ASTM procedure. And same thing for your incline and horizontal testing. It tells you for your equipment, you know, what it should comply with. Same thing here. It tells you it breaks out everything that you need. So you might be referring to 10 or 12 different standards between ISTA, ASTM, and anybody else by doing this, but you can see, you know, you have layer upon layer. So if you start off with the AIAG, RC9, and then it refers you to another test sequence, then that test sequence will refer you to, you know, all of the requirements from an ASTM standpoint. Is that clear, Brandon? Any questions?
Yeah, it makes sense to me.
Okay. Okay. So, so when you start talking about the test sequence that are referenced, so I just want you to get an idea of what those are. So I'm not expecting you to remember all of these. Because like I said, if you work in a test lab, you will learn all these and you'll remember them. If you don't work in a test lab, but you're running tests, it's important to understand what they do. So that's why, this one, it gives you a very detailed example of how it works. So you can see it, so you can understand. Let's see.
Which standards do we typically use in the automotive? Because I know a lot of the time I've seen ASTM rather than ISTA.
So it depends. I have seen mostly ASTM, but I would say more recently, I've seen some ISTA come into play with companies that are shipping electronic parts. I've even seen an OEM that many of the OEMs have their own standards, and they kind of do this, pick from the different menus and pull what they want to try to simulate what they have. So, I've seen one OEM that they're using ISTA. I didn't pull theirs up because I have confidentiality, but with them. But I think what I'll do is I'm gonna probably just write down a kind of a list of some of the things that they're looking at. And then that way you can see, let me see if I can find what they have. Actually, can I answer your question while we're on? See if I can find it. Let's see, just bear with me for one quick minute. Okay, so this one, for example, they're using the ASTM D4169. They're doing, so their shock is based, this particular one, their shock is based on D4169. Then they have a shock based on the ISTA 3E. Then they do a different, so that first shock is based on impact velocity. And then when they do the next shock with ISTA, it is a rotational edge drop. And then their next one is rotational flat drop, but they're going back to the ASTM D4169. And then they go to a vibration that is ISTA 3H. Then they're doing shock again, that goes back to the ISTA 3E. So, you can see they're basically making a hybrid, and this is one of the OEMs. They've made a hybrid test sequence. So their test sequence doesn't correlate with the AIAG RC9. It doesn't really correlate with, anybody else. They're making up their own, what they feel reflects the best in their environment of what they're seeing. And I can see this because this particular OEM, so first, most OEMs, they have, that list of suppliers that I showed you early on with the top 10 or 20 suppliers. Most OEMs are getting parts from all of these tier ones. So that means that I mentioned airbags, right? They're all coming from the same facility. So their sequence of, their test sequence, for airbags could be the same because they're all coming by, say, truck or rail or whatever. But then you have electronic components that are coming from overseas. So those are always coming on a boat. So though their testing might be, it might look like it's tailored to what they're doing specifically, this probably could be used by other suppliers, or I'm sorry, other OEMs and their suppliers. But that's what they've learned based on what they're receiving in. This is pretty reflective of what they see. So looking at this, I can tell you, so like they're conditioning with high humidity, which tells me that they anticipate a lot of their parts to come over the ocean by boat. Or maybe they're doing some manufacturing in warm places. So let's say maybe if they're getting parts from certain parts of Mexico, it's going to be hot and it could be humid. So they could accommodate for that. So if something's coming on a boat or going to be coming from a hot environment, then that would make sense. Impact velocity, they're using incline impact. That tells me that, they're looking at maybe trucks going uphill, but they're also looking at, pallet marshaling. Maybe they're seeing something with things sliding on an ocean, on a sea container. I'm just trying to think of some of the things they might have. Then when you start talking about some of the drop testing, that's probably going to be more reflective of just handling the boxes either within their facility or within their tier supplier facilities. And then they have selected the vibration based on a truck with air ride suspension. So that tells me that they're anticipating things that are going to be shipped domestically, whether they're coming from overseas and they get to the port, or whether they're being made domestically or even in Mexico or Canada, which is pretty typical. Those they think those are going to mostly get sent by truck versus rail, based on their quantities, based on the location of their suppliers. They anticipate that the majority of their product is going to be shipped to them by truck, and it's going to take several days to deliver it. And then they have, another drop test. So based on this sequence I'm looking at, I can tell that they're anticipating some handling, some humidity. The product's going to be trucked for sure. That's what they think. And they anticipate, being on the truck, there's probably going to be some sliding around in an angle, whether it's coming out on a, fork truck driver, or it's, the load on the truck is sliding. Those are some of the things that they're looking at. So does that make sense?
Yep. And it's interesting because what I'm taking from this is pretty much you don't have to be bound to one testing standard. You can just pull from a variety of different the testing standards.
Right. So, I think the most important thing is that you want to understand your environment so that you can test properly, because your test is to anticipate any events that could cause damage.
Gotcha.
So, that's why I gave that example early on in this lecture, that if you're testing for, what the current state might be, lower volumes or one single part, and it's all shipping the same way no matter what. But if you increase your volume, or maybe you start shipping from a different supplier, maybe you see in automotive a lot where people go with the low cost country. I think we're seeing less of that now because of the pandemic, but with the low cost country, I've seen companies change their supplier every 3 to 5 years. So, first they're maybe getting it from down south, then they're getting it from Canada, then they get it from Mexico, then they're getting it from Eastern Europe, then they're getting from Asia, then they're getting from South America, and they'll just keep switching to get the lowest price. But every time they do that, it's going to impact how it's shipped. You know, if you're an auto supplier, if you're an auto company in Metro Detroit and your supplier is coming from Canada, you know, an hour away on a truck, that's a whole lot different than, you know, now you've switched and you're coming from Eastern Europe or you're coming from South America because it's a low cost country, but now you're spending a lot more money, you know, from a transportation standpoint to ship it. So the part itself may cost less, but the transportation costs may go up as well as the environment. So, you know, if you're shipping something from, say, the interior of China versus, you know, Canada, or even say if you're in Detroit, Metro Detroit, or if you're in, you know, if you're in the Southeast corridor and you're shipping literally across the street, it's going to be, your environment is going to be totally different. So yes, you're right. It's important. You're not stuck. The AIAG testing, it's called a returnable container performance guideline. It's a guideline. It's not meant to be all or nothing. It's just a guide to give you a starting point. So if you come in and you're like, I don't have any packaging standards, where do I go? What do I do? You can go here and start using this and then saying which ones work for me, which ones do I need to change? You know, why are these the ones that were outlined in this guideline? And again, you know, you see this test, these tests are for bulk containers. And they could have, this is an access door, or it may be solid like this with no door. It doesn't matter, because once this is closed, this acts as a solid wall. Just looking at the time here. And let's see, so again, so tomorrow I'm going to go through some of these tests here. And I pulled up, you know, that example already and just kind of read through some of the things that they're doing. But I just wanted to get an idea of, you know, how different these tests can be. But the key thing is understanding, one, your environment, two, what the hazards are in your environment, and then three, how do you simulate? What tests most are the best for simulating the environment that you've determined that your products are in? Okay, so I skipped over that and I'll go back to it tomorrow, but you know, here's some other tests. These are for individual totes. So those are gonna be like the handheld totes. And then also there's some for plastic pallets. So again, the tests are pretty similar because the environment will be the same. You're gonna have, you know, this pallet with totes on it, or maybe you have, you know, this bin with without an access door. You know, you can see like the drops on both of these. Vibration, again, from the ASTM D4169. Okay. And pallet testing. So again, tomorrow I'm going to pull, I'm going to see what standards there are with AIAG for testing. But you can see what some of these tests look like. So, you know, some of these you look at it and it's like, this kind of looks jury rigged. It's got, you know, wood blocks here, but the key is repeatability. That's the thing with the testing. So Brandon, you mentioned about having some freedom. And it's true. The important thing is you're trying to simulate your environment to determine what best protects your parts. This is not automotive, but you know, years ago I did packaging for servers. So the computer servers that go in the data centers, those rooms that are really cold, and they're, really, when you go inside, they're super cold, and the IT guy sitting up there, like, it's not cold, but um, those servers are used for, like, I know that the movie industry uses those servers. So when you see a Disney movie and you see all those high-end graphics, that's how much data it takes. They will have a whole data center full of these servers that are the size of a refrigerator. But with that being said, these servers are worth millions of dollars. Each one individually is millions of dollars. So they have to be protected. And servers used to be shipped this empty cabinet, and then it would ship individual boxes with the keyboards and the monitors and all the wiring and the actual CPU. The server is like basically a CPU, like the old school computer, but it's really big. And then they have what's called like blades, which are the memory, the pieces for the memory. So those are all have to be put in. So they'd all come in individual boxes, and they would load them into the cabinet. Well, Dell started shipping these cabinets full and completely set up. So instead of it getting to the data center, and the people in the data center would have to basically know how this needs to be arranged and put in, Dell set it up so you can order your server and it would be shipped to you with everything in it that you needed. Set up, all the cable management, all the wiring, everything that you needed would be set up in here. So, even like your cable, like your LAN cable that would go into the ceilings of the computers, that would be set up for you. So the company I worked for needed to compete, but they didn't have a way to test the packaging that they came up with. So, I had to go through and evaluate, how are these shipped? When they're put together, what happens to them? Okay, they're put on a pallet, and then that pallet actually is a shock pallet. It has foam in it. So it has inside of the pallet, you would see styrofoam. So instead of just being able to see through it, you would see styrofoam blocks on it. So I guess it would kind of look something like this with the styrofoam blocks inside of it. So if you looked at it from the bottom, you would see this. If you looked at it from the side, you would see that foam in it. But anyway, I had to look at how that shipped in. Is it on a pallet? When does it get taken off the pallet? It would get taken off the pallet because the server had casters on it, but it still had all of the outer pack on top. So it would have a corrugated wrap on it, and then it would have cushioning and corner post on it so that the cabinet would be protected and still had some shock protection. So another thing was that these would get moved off and on freight elevators most of the time, because in order to get them into a building, they'd have to be taken up a freight elevator. They'd also have to go up a ramp once a truck was opened up, and then went to take them off the truck. Sometimes the truck will come up to the dock doors, but many times when you pretend this is a dock door, the pallet, that shock pallet would get emptied, and then it would come off the casters into the dock. And sometimes there was a ramp. So sometimes you take it off the pallet, and that would be pushed by the casters up the ramp into the dock door or a freight elevator. And then these units couldn't get tipped more than 15 degrees. So there were a lot of things that went into these, what could damage these racks, with and without packaging. But they didn't have any test sequence for it. So one of the things, again, I had to do was understand the whole process on how they got moved from when they were first packed all the way until they got to the final customer destination, and then come up with a way to simulate it. So one of the biggest issues was going into a freight elevator, because there was a bump And, maybe when you get on an elevator, you might have maybe 3 inches, 2 to 3 inches of a gap between the elevator floor and the floor of that building. And at that bump, that caster would get into that bump, and you had to make sure that you had a test that would simulate what that shock event was, because that was a shock event and that could cause damage to the servers. So my understanding is that it's been probably 20 years now, but they're looking at making a test sequence for servers a standard. So, at some point it would be a standard, but back then there wasn't any standard, but it's been proven repeatable. It's repeatable and it simulates the environment. So, that would be an example of what it would look like. So, I hope that answers your questions for today. So tomorrow I will continue on chapter 3. I will try to pull some more AIAG examples so you all can see, and then try to explain some of these test sequences. And if you guys have any questions, feel free to send them. Brandon, any last questions before I sign off?
No, I'm all good.
Okay, great. And I look forward to seeing you all tomorrow, or you seeing me tomorrow. All right, thanks. Bye-bye.